all those who are joined offline and online. And profusely I thank Dr. Mohan Kumar for having accepted our invitation. And I invite the Dean PG Studies who has supported us both financially and physically for this program. Now, Dr. Senthil, Dean PG Studies, can you throw some introduction points?
Okay, thank you, Dr. Balu. At least finally today's speaker from net zero carbon to now internet has a lot of issues. So finally it is settled. I am happy that the Dean FC and RI is arranged satellite the audios and videos and all the online participants who are waiting for the past past an hour. Please, sorry for the inconvenience. Today I really thank Dean Forest College for arranging the excellent, wonderful speaker, Dr. Mohan Kumar, ex-Vice Chancellor CAU. And really it's a great occasion that Forest College and Metropolitan is arranging the eminent speaker. Also today is going to talk on the nature-based solution for achieving the India's net zero emission and for biodiversity conservation. And this is really a boom for not only the forestry people but also for the other scientists working in agronomist or the environmental scientists who are working for the carbon net zero. Really this net zero, which responsibility for every individuals, organizations or the businessman, everybody has to look on that. Again, the carbon credit, the forest is a major role they are going to play. Which tree species we have to plant? If you plant a tree species, what kind of carbon we can able to make it a net zero? How we can make zero footprint? So I think these are all the things that today we are going to hear from the speaker. I really now that it's little late, so I will I really thank the because of short of time. I really thank the speaker and also the Vice Chancellor for helping us to make arrangement for these all endowment lectures. I hope the audience will enjoy the lecture. Thank you for giving me the opportunity. Let us go. Let us invite the speaker, and the mic is handed over to the Dean Forest College.
Thank you, Senthil. Before starting the proceedings, okay, there is welcome to the speaker. Before that, I'm really happy to introduce Dr. Mohan Kumar sir for the entire forum because he is the most renowned agroforestry scientist. He worked in Kerala Agriculture University in different platforms, including as a dean for 30 years. After his service, he has moved as ADG Agroforestry ICAR. After a successful tenure in ADG Agroforestry, then he moved to Dean in Nalanda University. After a successful tenure at Dean in Nalanda University, he was prestigiously honored by the Government of India by selecting him as a Vice Chancellor in Kerala Agriculture University and Arunachal Pradesh. And recently, the tenure of Vice Chancellor has been completed. Sir is a very rich, experienced agroforestry person, and world-renowned Dr. Nair, the agroforestry specialist, he is closely associating with him for more than 3-4 decades. Now, in the entire country, he is the senior most agroforestry scientist, having a rich knowledge on agroforestry, emission, carbon sequestration, everything and all discuss of forestry. We are very privileged, sir, and we have PNA and our Vice Chancellor. We are very pleased to invite you for this, and we are very honorable also to invite for delivering this lecture. On behalf of each and everyone, and we welcome to sir. And I invite Dr. Maninagan to give him a flower made of Kapoor. Well, for want of time, without having much time to spend, I request Dr. Mohan Kumar to deliver this endowment lecture on nature-based solutions for achieving India's net zero emission targets and for biodiversity conservation. The perspective of agroforestry. Please. Professor Balasubramanian, Dean of the Forest College, Metropolitan, Dean PGS, who has joined online from Coimbatore. All of the students, I think students are online. So good afternoon to all of you. It's a pleasure for me to visit this metropolitan campus once again. I have been a frequent visitor of this campus several years ago, but for the last 10, 15 years, probably I did not visit this campus. So it's a happy occasion for me to visit this metropolitan campus, and I see also a lot of transformations within this campus, all very good transformations. The infrastructure has improved a lot compared to my probably 10, 15 years old previous visit. So my compliments to all the authorities concerned, the dean, present dean, the previous dean, Dr. Parthiban, and also, the university authorities in Coimbatore. So, Forest College Metropolitan Campus, I think, has got a very bright future, and I wish all the very best for all the faculty and all the students who are here. So, as a token of my appreciation, I just want to present one of our a copy of our recent books to the Dean called the Dean Forest College and Research Institute Metropolitan. This book, I hope. Okay. Okay. This book. Okay. This is an introduction to agroforestry, published by Springer, authored by Professor P.K. Ramchandran Nair, myself, and Nimla Nair. It was published in 2021. We consider it as one of the authentic pieces on agroforestry in the world. I request Professor Balasubramanian to accept it from me. Thank you, sir. Thank you. Thank you, sir. So very good work. Right. Thank you, Professor Balasubramanian, for accepting my humble, gift of this copy of our textbook on agroforestry and Introduction to Agroforestry, second edition, published by Springer Nature. Okay, so I hope the students will be able to read it, and in case if they already do not have a copy, probably they already have a copy, or maybe more than one copy available in the library. But I hope this will also help in the days to come, particularly to the students, the postgraduate students who are working on agroforestry. Okay, with that brief introduction, I think time is short and we are running very late. So by this time, I think I should have finished my lecture. Now I'm barely starting it. I'm going to talk to you today about nature-based solutions for achieving India's net zero emission targets and for biodiversity conservation, a perspective on agroforestry. As all of you know, climate change and loss of biodiversity are two major challenges that the humanity faces today. As you can see, I hope you are able to see the bottom half of my slide. So the bottom half shows the annual temperature trends over the last century and also the annual precipitation trends during the last century from 1900 to 2000. So there has been an increase. There has been a pronounced warming. And also there has been increased precipitation. And as a result of all these things, there have been drastic losses in biodiversity. The picture on the right-hand side, right-hand corner, is that of the golden toad, before peregrines, which is considered to be the flagship species for amphibian biodiversity conservation, which has become extinct in 2004. It was reproducing profusely in Costa Rican forest, but by 2000 years, primarily because of climate change, it has become extinct. So I will talk primarily about two things. How can nature-based solutions such as agroforestry can help achieve climate change mitigation of their case in India, and particularly in the context of in the run-up for the net zero emission targets which our Prime Minister has recently, last year announced. COP26. And how agroforestry will also help address the question of biodiversity challenges that the world faces today. Okay, so this what you see on the screen is the global change triangle. So as you can see, I mean climate change is a major driver of biodiversity changes or loss of biodiversity, and both biodiversity changes and climate change are driven by land use changes. So we are all in the arena in the segment called land use changes, which is a major contributor to climate change. It can also act as a major sink for carbon. Therefore, this land use and land use changes are extremely important from the perspective of both climate change mitigation and also from the perspective of conserving biodiversity. So I'm sure all of you must have heard about these major international agreements like the Kyoto Protocol, Paris Agreement, and also India's net zero emission targets. Kyoto, as you probably know, Kyoto Protocol has operationalized the GHG emission reduction in accordance with the individual targets pledged by the so-called Endowment countries and the economies in transition for the first time, and it has recognized carbon sequestration through afforestation and reforestation as a form of GHG offset activities, and land use change and forestry, the so-called LULUCF approach gained popularity in the context of this Kyoto Protocol. And CDM initiatives permitted industrialized nations that have made commitments to reduce their greenhouse gas emissions to invest in mitigation projects in the developing countries. This, however, has a flip side, which is illustrated in this particular cartoon. You can see, a lot of debates about climate change. I'm not going into the details of that because that itself can be a topic for one full-hour lecture or more. So, as you can see, this cartoon shows, they're stuck in an elevator with the US at the UN Global Warming Conference. The bottom line is that if a ton of carbon is sequestered through CDM activity, it allows for another ton of carbon to be emitted somewhere else via the offset trade. And there is a broad concern that net emission might increase if the stored carbon is re-emitted. Okay, Paris Agreement, more recent, it is a legally binding agreement. Kyoto was not. Paris Agreement is a legally binding agreement. The nation. So you can see the cartoon on the right side, the Noah's Ark-like situation where most countries have agreed on this problem of climate change, but there are some, countries which have probably not agreed. Of course, the US, when Obama was president, he signed that, but then when Trump he withdrew from the agreement. Anyway, I'm not going into the details. So, the Paris Agreement, they actually wanted, or it aims to limit the increase in global average temperature to well below 2 degrees Celsius above the pre-industrial levels, and preferably pursue efforts to limit the temperature rise to 1.5 degree Celsius above pre-industrial levels. And for this, in order to accomplish this, GHG emissions must peak no later than 2025. It's very close. 2025 is here now, 2023, and then decline by 43% by 2030. This is a Herculean task, and we have to see. We will see what is going to happen. Whether the world will be in a position to achieve this target. And then, of course, in the Indian context, India is the third largest contributor of global, energy use and anthropogenic carbon emissions. And we have some numbers there. I'm not going to read out those numbers. Total emission increased, as you can see from this graph, almost linearly, especially after the year 2000. Total emissions in India has increased, and of course, 75% of this actually comes from the energy sector, and the food system, including crop and livestock production, is responsible for up to a third of the total anthropogenic GHG emissions. Okay, and in that context, only our Prime Minister made an commitment actually, at the COP26 summit in Glasgow, UK, in November 2021, COP26 meeting. And India is committed to achieve net zero emission, carbon emissions by the year 2070. And for this now, we have to reduce India's total projected carbon emissions by 1 billion tons by the year 2030, which is again very close. And lower the nation's carbon intensity of the carbon intensity of the nation's economy to less than 45% by the end of the decade. We have to see whether we are going to achieve all these targets. And of course, most of the emissions actually, greenhouse gas emissions actually come from the energy sector. The affordable sector, however, can contribute, and there lies the role of forestry and agroforestry. So, in the energy sector, you probably need to know, you need to implement new technologies for improving energy efficiency, carbon reduction, green fuels. A lot of actions, a lot of activities are actually going green hydrogen, green energy, so on and so forth. And this India, I'm sure the students are mostly familiar with this India's third biennial update report of 2021. I mean, this is submitted periodically to the NFCC. And so according to this report, the agriculture sector generated about 14% of the total India's greenhouse gas emissions, 14%. And throughout the 90s, however, most of this actually came from land-based emissions caused by changes in land use, about which I earlier hinted, and particularly the expansion of agricultural lands into carbon-rich forest areas, forest clearance. And of late, however, you can see, okay, you can look at the line graph on the right-hand side. The total red line is actual total, and then of course entry permit livestock related emissions that constitute the second. I mean, most of it actually. About 54% of the total agricultural sector emissions in the country actually comes from the livestock, mostly as methane through entry fermentation. Okay, entry fermentation, of course, a little bit of 14% or so. Fertilizer, manure management, rice packing, food waste is also a significant contributor to the greenhouse gas emission scenario in this country. Huge amount. India, of course, with respect to food waste, is probably in the world after US and China. In respect of food, huge amount of food is waste, and this is actually contributing a huge amount of greenhouse gas emission. We have to do something to reduce food waste, so that if you want to achieve the net zero emission targets by 2070. Okay? All the forest fires, our forest students, forestry faculty, they all know about this. Forest fires are a source of this forest fragmentation, but the forest resource base of this country has kind of stabilized around 71 million hectares. Okay, it's about 21 plus percentage of the total geographical area of this country, and you will see sequestered, about 15% of total India's carbon dioxide. So it's a net sink. The land is actually, or land use sector in this country is actually a net sink for greenhouse gas emissions. Although many of these, now the forest fires and other things may emit a significant amount of greenhouse gas emissions. Still, if you look at the statistics, the line graph that you have seen in the previous slide shows that is still a net sink in this country. So this one actually shows, all these entry fermentation, the methane emissions, and NBS like forests and agroforests have got a major role in trapping, in absorbing carbon dioxide emission, because of historically, not only in India, in other parts of the tropic, even now it is continuing in countries like Brazil, the Amazon region, and also in Africa. So the reforestation still goes on unhindered, and this is contributing to a huge amount of greenhouse gas emissions. But reforestation, afforestation, agroforestry, they have a major role. They can play an important role in sequestering this carbon dioxide. That is what is shown here, trapping carbon dioxide emission because of all these forest clearance. Okay. Nature-based emissions, I'm not going to read this definition given by IUCN. So the nature-based, another related thing is regenerative agriculture. We just become fashionable of late, regenerative. There are various forms of regenerative agriculture. I hope you can see this, right? And there's too much like, I don't know. So there are various forms, and again, not going to explain this slide in detail. There are various forms of regenerative agriculture. So agroforestry is one of those, as you can see, and any regenerative agriculture practice is expected to enhance the carbon stock of the soil and enrich the soil's productive capacity. Okay, so agroforestry. Coming back to agroforestry, I'm sure forestry students must have done this, thought about this. Mathers forest transition curve, which shows that, which describes that, the forest resource base of any developing economy or developed economy may show an exponential decline over time and stabilize and then eventually increase. That is what is shown in this curve. So this curve shows that. This is the kind of depiction of the methods forest transition curve. Okay? Next slide. Okay, and then for agroforestry. So this India is also following this particular trajectory. Now, if you look at the FSI reports, State of Forest, State of India's forest reports, now earlier gradually our forest resource base has been increasing and has kind of stabilized at around 71 million hectares right now, about 21%. Previously it was less. Okay, so it is increasing. So India is also following, and most of the developing countries in North America and also Europe also showed this pattern. Hey, over a century ago, 100 years back or so, Europe and North America also experienced this kind of high deforestation rate in the development of, in the context of economic development and also increasing demographic pressure. Okay? And there are, of course, plantations are also important, in this context for enriching. So this, on the vertical axis, what do you see? Carbon stock, tree basal area, whatever. Or even it is a proxy of forest area. Forests have, of course, has got very high plantations. The carbon stock, biomass carbon stocks are relatively low. Still, they can help in sequestering carbon and helping us to accomplish attain the net zero emission targets. Okay, talking about agroforestry, there are various kinds of agroforestry systems in India. Right? Okay. So, on the left hand side, what you see is the popular plus wheat agroforestry system in the IGPA, Indo-Gangetic Plains area. Major agroforestry. On the right hand side, what you see is again from Emerald Nagar is actually the private capital of India. Some of you must see. So there, they also grow a lot of copra in combination with a whole range of agronomic, not only agronomic, horticultural process. Okay, you see in Chowdhury, you see mango, you see persimmon, and of course in a combination with the copra. Okay, then not only in India, other countries also. What you see on the top left corner is viticulture. And I'm jumping. Jumping is viticulture is one of those forms of regenerative. Viticulture is a form of regenerative. Earlier, grapevines are used cultivated as monocultures. Now this picture is from Montpellier, France, where the French people, of course, France is known for all the wine industry, various hundreds of brands, thousands of brands of wine. Wine and cheese, these are the two things that the French are famous for. So they are now resorting to this as a form of regenerative agriculture to grow trees in association with the grapevine. Okay. And then, of course, right hand side eucalyptus. That picture is from Brazil. And then again, this is also from the bottom left is walnut trees in competition with I think they grow wheat there. Of course, we cannot be seen. And on right hand side, you Chinese chestnut in the US in southeast street. So together with wheat. So various kinds of agroforestry systems are common. In most parts of the world, Indonesia, they grow a lot of Sesbania trees on the aerial barns. China, popularity is the agroforestry. Right hand side top, you find, border trees of teak and mahogany. In Nalanda district, I used to work in Nalanda. So Nalanda district of Bihar, and then bottom you find, the Sencas plus Acacia leucopoia in Tamil Nadu and Kangeni. Okay, so but home garden constitute probably one of the most unique forms of agroforestry. So most parts of India, Kerala is famous for not only India but other parts of South Asia and also Southeast Asia. Home gardens are very popular. They actually represent intimate multi-story combinations of various trees and crops grown in association with domestic animals around the homesteads. You can see some pictures. They provide a range of ecosystem services pollution, cultural regulatory, etc. Okay, so in Southeast Asia, Indonesia, you find a lot of home gardening, and this Dhamma-based agroforestry home gardening are very popular in Sumatra Island of Indonesia. So you also find on the right-hand side a home garden in Sri Lanka. So the Chaga home gardens are famous now. There, home gardens are not only providing a range of ecosystem services, they also provisioning and other services, they also are important from the point of view of providing cultural ecosystem services. People know the tribes called Chagas dance around the home gardens and all that. Okay? Sorry? Oh, let's again from the what only say, and you may also see people like now there and Shyam also. So this picture was taken when we were in the 2009 agroforestry congress in Nairobi. Okay, so kind of I'm not going to the details of this particular slide now. Home gardens are important. No, in providing a range of ecosystem services, a point that I already made, and if they are helpful in helping us to meet the SDGs. Okay? By 2030, the United Nations has announced these 17 SDGs, and the time frame is 2030. But the COVID has pushed that back. The accomplishment of many of these SDGs, but as you can see from, I'm not going to detail a lot of details there. So in case if you are interested, you can read this paper, Sharma, Meena and Kumar in Agronomy for Sustainable Development. Okay, it can provide a range of ecosystem services and help us to achieve the sustainable development goals. Many of these, all the 17, majority of them will be home gardens will help us to achieve. Okay. So from the point of view of agroforestry, climate change mitigation, so there are three major roles agroforestry can play in the context of climate change mitigation. One, of course, is carbon sequestration, which is nothing but creating new stocks of carbon in the soil and biomass. Okay, and it can help probably increase the size of the global or the terrestrial carbon sink and carbon substitution of energy rich materials by like glass, cement, etc. by renewable natural resources through maybe fuel production, increased conversion of biomass into durable wood products for use in place of energy intensive materials. They like concrete. They substitute concrete for glass with energy, carbon intensive material with wood and carbon conservation, which through this agroforestry can help ease pressure on natural forests so that there will be more carbon sequestered in our natural forests. And it is particularly relevant from the perspective of all these three United Nations conventions, like the UNFCCC, UNCDD, and also UNCCD. I'm sure you are familiar with all these things. I'm not going to the details. So, but the amount of the carbon sequestration potential of agroforest is substantially variable. Some time back, we did a review of this, and we found that the above ground carbon stocks in agroforestry systems across India range from, uh, 0.23 to 23.55 megagram or ton carbon per hectare per year, and below ground is between 0.03 to 5.08 megagram carbon per hectare. And there is a huge amount of variability with respect to the carbon stocks in agroforestry systems. Primarily location, elevation, altitude, and so many factors are influencing the carbon species. All these are major determinants of the carbon stocks of agroforestry systems. Talking about geographical locations or location, Western Himalayan and humid tropical agroforestry systems are generally characterized by much higher carbon sequestration potential than the arid and semi-arid regions, and soil carbon stocks also varied considerably from 10 megagram carbon per hectare for the Sisyphus mauritiana plus grass system in western Rajasthan to as much as 229 megagram carbon per hectare in the northeast state of Bengal. So Bengal in the northeast have got very high potential for both above ground carbon in sequestration as well as below ground. Okay, and as I mentioned about elevation mean or altitude, we have also influenced. And in one study, we found that the carbon sequestration potential of home gardens in Kerala state showed a modestly negative relationship with the altitude. As you can see, altitude increase, there was a modest reduction in the carbon sequestration potential. Size of the hole, structural factors like the size of the hole. And a couple of our studies have indicated that the smaller home gardens are generally characterized by higher carbon sequestration than the large size on a unit area basis, not on a total home garden basis, but on a primarily because of there's more species packing in the smaller gardens compared to the larger one, and then also better management perhaps. Okay. So for soil carbon sequestration is grossly variable. I mean, anything between 30 to 300 tons per hectare up to 100 centimeter depth profile. And I'm sure most of you, the students must have heard about the 4 per milli soil carbon initiative, which was launched during the 2015 COP meeting at Paris. So the French actually made this proposal and it was kind of adopted at the COP meeting. But then this is not a normative target for every country, but a kind of aspirational goal. It is good that if we can accomplish, because there are no, what it implies is that every year the soil carbon stocks should increase by 0.4%. A huge target, difficult to accomplish. So that is why they declare that it is not a normative target for each country, but a kind of aspirational goal. So it's good, but there are various kinds of best management practices, like the TNU has developed those intensive industrial agroforestry models. So such systems, BMPs, have got a great role in promoting soil carbon. And also the intensive silvicultural practice, short rotation, intensive agricultural, forestry production systems have a great influence, great role in augmenting soil carbon stuff. So it may help in achieving this aspirational goal of 4 per million. Okay. There are various mechanisms for soil carbon sequestration. I'm not going into the details of this big topic to be discussed. Basically, there are 3 mechanisms for soil carbon sequestration. These are, biochemical recalcitrance, physical protection, chemical stabilizer. Biochemical recalcitrance means formation through repeated polymerization of the organic materials within the soil through the activity of the microbes. Various kinds of aromatic polymers and other complex organic structures are produced which are resistant to further breakdown. So lignins, polyphenols, all these are examples of those aromatic polymers. So woody species having higher content of lignin or polyphenol content may help in increasing the soil organic carbon stocks. And then aggregate stability, there are various kinds of aggregates, micro, semi-micro, and macro aggregates. The smaller aggregates can protect. The carbon that is entrapped within the smaller soil aggregates may remain stable for a longer period of time compared to the larger aggregates. And then organo formation of what is called organo-mineral complexes within the soil. This can happen with either polymerization. So these organic compounds can combine with its producing the so-called organo-mineral complexes. This formation of these organo-mineral complexes can help carbon sequestration. Okay, and there are, these are agroforestry therefore from the soil and also the above ground carbon sequestration potential are kind of, although they are not considered to be a win-win situation, although they are really, in my opinion, but generally speaking, they are not considered to be win-win. That is high carbon and high profit, so double win. But they are generally regarded as no regrets options with medium to high profit and medium carbon stocks. So no regrets option. Rather than they can be described as no regrets option rather than being described as win-win situation. So there may the benefits, potential benefits that the farmers who are practicing agroforestry is, they can sequester carbon, the sequestered carbon, the carbon credits, the CDRs and so many things. I'm not going to be talking. Can be sold in the carbon, so-called carbon market. It is kind of carbon market also there. But immediately after the Kyoto Protocol, there was a huge amount of enthusiasm about all these land use. Of course, energy sector CDMs are still probably working, but land use sector, land use change and forestry sector, CDMs, although there was a lot of enthusiasm initially, there's probably a lot of hype and probably nothing much work. In India, only a handful of CDM projects. I'm talking about 10 years from 2008 when the Kyoto became operative. 2008 to 12, that was the time. ICFR was the nodal agency for this UNFCCC CDM register. But then, since they had to remit some money, I was attending one of the governing board meetings when I was working in Delhi. So they decided in the governing council came. They decided to withdraw from this because they are not able to make any money through registration because no projects were registered with them. So they had to withdraw. Every year, the renewal of this registration, they have to make some upfront payment. And they found it, as I was using proposition. So CDM, that's about, but still, CDM, sync-related CDM projects could probably, at least in theory, may represent financial inflows, especially to the developing country farmers. And there could be definitely gains in productivity associated with that, because carbon sequestration means increased carbon stocks in the soil organic matter content, which can sustain agricultural productivity. So there may be improved productivity of crops when you have higher augmented status of soil organic carbon. So that's why, medium, kind of carbon and also medium profit. So the next bullet, what it says is the profitability of the land use related CDM projects may be questioned. Okay, and primarily because of the problem with ICF, which ICFR experience I just now mentioned. But the problem is the CDM, land use related CDM, the high transaction costs and huge volatility of carbon prices in the international markets. So the carbon price was fluctuating like now. I think when all these Kyoto became operative, it was like 20 or 25 dollars per ton, which I think another 5-6 years. Right now, I don't know the price carbon in the international market, but it came down to less than one in between. Right now, probably there is some increase. $10. $10, right? Yeah, but it came down to around $1 per ton. So most of these land use related CDM projects the non-viable propositions. Okay. Still, in the energy sector, you find a lot of these cap and trade schemes. I'm not going to, that's a big topic now, I'm not going into details of that. And since 2008 and all, there were a number of, or even a little before, participatory carbon trading projects, like in Thailand, in Mexico, in Latin America, and of course, voluntary offset markets, compulsory markets, so many things are there. Not going into the details of all those. But after the Paris Agreement, okay, what you found in the UN climate change has become a new partnership with what is called the ACX. I think that is working. The earlier ones are probably no more functional, but for the energy sector, energy CDMs, I think are still working. The cap and trade schemes and some other schemes are. Okay, then the second mechanism is carbon substitution. Biomass utilization as carbon neutral energy. Now there are both direct energy substitution also and also indirect material substitution. Indirect material substitution. Nowadays, of course, Government of India has launched this, 5%, substitution of coal. I mean, raw material in the coal-based thermal power plant. There's a program initiative called Samarth. I'm sure some of you must have. Samarth actually is an acronym stands for Sustainable Agrarian Mission for Use of Agricultural Agro Residues in Thermal Power Plants. Similarly, wood chips are also used as a substitute for coal in the coal-based thermal power plants. The coal is, all these fossil-based energy sources are major emitters of greenhouse gas. So if we can substitute coal or even petroleum with biofuel or bioresources, that will help us to accomplish the net zero emission targets in every year. And direct energy substitution, of course, all these first generation biofuels, second generation biofuels, third generation biofuels, biodiesel, butanol, gasoline, methane, ethanol, vegetable oil, so many things are happening now, especially after the announcement last year or the year back, Prime Minister for this net zero emission targets. Okay, Brazil and US are leaders as well as biofuel production. I'm not going to detail some of these Brazilian biofuel plants, which I visited sometime back, pictures are there. Okay, Brazilians also grow, there's a Macauba palm. It's an important source of, biodiesel. Okay? It contains, I think, high content, maybe 50%, I'm not really sure, you can check Macauba palms. So they cultivate this. Yeah. When we were visiting that, we thought of having some kind of agreement with India. But the Brazilians are very clever. They will not share this with us. Okay. So Macauba is a very promising species. In India also, we have, earlier, we have that so-called failed Detrofa experiment. But then after that failure of Detrofa, several other tree-based oil seeds were kind of promoted, but I think that initiative was lost in Buddhism. I don't think that it is taken anymore very seriously. But the Detrofa was taken very seriously, but that was under a false notion that Detrofa could probably solve all our problems, but it did not solve any other problems, and all problems remained there, and Detrofa also just vanished into thin air after that. India ethanol production, of course, most of it actually comes from the sugarcane industry. Okay, right? I think last 2 years back it was 1,410 million liters. So taste curve still has got, I believe, I think it is, my information may not be up to date as far as the taste curve is concerned, but a few years back when I was in conference on them, they claimed that they are good for the from the biodiesel production. Maybe it is there. Some of we can check that. Okay, so some of the promising gem class of and all that. course, there is potential for that. Selection, improvement, agronomic management. So carbon substitution, energy, direct energy and indirect material. Many of those materials, you put a substituting energy intensive materials, I think that will help us to be more greener in the days to come. Like the FAO got launched this program, sustainable use of sustainable wood for a sustainable world. They conducted sometime back, they conducted a seminar also on this. Okay. So the other aspect of agroforestry also can help in finish in another 10 minutes. Is it okay? Carbon conservation. So, there's a theory called agroforestry deforestation. So, not a theory, hypothesis. Agroforestry deforestation hypothesis, which says that if we can meet most of these materials, provide all these materials for which people usually or society usually depends on forests through other sources, agroforestry, then that may help conservation of natural forest ecosystem. But if you look at for any concrete proof of this hypothesis, you will not find. But still, agroforestry speak that if we can promote agroforestry and provide all those materials in a vacuum, but of course, even now, it's true also to some extent. Logically, it makes sense, but if you're testing that hypothesis with some data, you don't get data, at least in my knowledge. As far as my information goes, there's no data to support this hypothesis. But logically, it may work. If we can, like even now in India, green drilling has been banned for the last couple of decades. And most of our requirements actually come from sources other than natural forest ecosystems, natural forest. So if we can meet all those timber, non-timber, or whatever other products for which we depend on forest, society depends on forest, and probably there will be better forest conservation. And of course, there are REDD+ mechanisms which actually tries to valorize the forest ecosystem service and also trying to address the degradation and deforestation, which has been still now happening in a big way in many countries, especially in the tropics. So the REDD+ mechanism has been there, and Indonesia and Brazil has made a major headway as well as this REDD+ mechanisms and as well as my information was India papers. Significant accomplishment as well as the objectives of this REDD+ mechanism. But we talk about REDD+ mechanism. Foresters talk about the foresters sitting there and talk about the REDD+ mechanism. But on the ground, I don't know anything significant is happening or not. We can check that. So if we can conserve forests through avoiding deforestation, it's called avoiding deforestation. There will be many positive externalities also, like biodiversity conservation, about which I will be talking in a moment, of watershed protection and also poverty alleviation. So the biodiversity crisis, I started with saying this also, this lecture by mentioning about biodiversity challenges also. The IPBES, Data Government Science Policy Platform on Biodiversity and Ecosystem Services, brought out a report, a series of reports. Of course, the one I'm referring to is 2019 report, which says that it's a summary for policymakers around the world. It says that nature is declining globally at rates unprecedented in human history, and around 1 million animal and plant species are now threatened with extinction, many within decades. And of course, the conservationists are familiar with the so-called biodiversity hotspot concept, and this has been a running point and mantra for all the conservation efforts, for channelizing or directing funding and also from philanthropy. A lot of efforts, currently there are 36 biodiversity hotspot areas which qualify, 36 areas which qualify as biodiversity hotspots and represent nearly 2.4% of the plants are sustained, more than 50% of the endemic plants, and nearly 43% of the world's bird, mammal, reptile, and amphibian species. But the important point is that more than 90% of the global biodiversity resources are actually found in human-dominated tropical landscapes, which are outside the purview of the so-called biodiversity hotspots. And they are out in the cold, and therefore they are called biodiversity cold spots. Okay, some authors argue that hotspot concept actually leaves out vast expanses of the globe with considerable biodiversity in the cold, and these are, of course, as I mentioned, the so-called biodiversity cold spots. Most tropical agroforestry systems, especially multi-state agroforestry systems like the tropical homeland, are actually harbingers of biodiversity, but there is little or no international or even national attention to focus on these tropical human-dominated landscapes which conserve a vast amount of biological resources or biological diversity. And bringing conservation measures to such landscapes will be a step in the right direction. And home gardens are stepping stones and refuges for the conservation and enhancement of biodiversity. And loss of biodiversity, as you know, can lead to a decline in the ecosystem services. Series of thus reports which show that clearly, and climate change is a major driver of biodiversity losses, and biodiversity loss is a major principal driver of loss of ecosystem services. And one of the main important ecosystem services is pollination services. So with the pollinator population decline in the world over, primarily because of agriculture, intensive agriculture. So many places of pollinator populations are declining, and eventually, I mean, this has already happened a few years back. The picture is not very current. For 5 years or more than 5 years old picture. In China, what they are right now doing, what they have been doing, is that they hire people to pollinate orchard crops like apple and all that. So the birds finding and standing on the tree is actually pollinating the flowers. So the insects are not there. Pollinators are absent. So we may have to do it other places also. But China, they are doing it already. Okay, so home garden agroforestry systems in general, and home gardens in particular, are key of the loci for biodiversity conservation. One study, this was one fellow is a Kabir from Bangladesh, and where it is boys, a PhD boys, and the AIT, Institute of Technology. But now they are also recognized that in Bangladesh, as many as 419 species, of which about 6 are IUCN places found in the whole garden. So home gardens are important. Agroforestry systems are important even for conserving some of those threatened species, the IUCN listed species. In Kerala also we did a study, we found that across the landscape, in the sea coastal line to high ranges, we recorded 72 species. Of that, 43 were in the IUCN list category. Okay, home gardens are important, no? That way. And therefore, many of these agroforestry systems are considered to be Sarkar system reservoirs of biodiversity. Sarkar system reservoirs means these are in situ, ex situ, and Sarkar system. Sarkar system means preservation of planted or relic trees and wildlings on farmlands where natural forests or woodlands and again the same trees existed once but has been lost or altered significantly through agricultural expansion. So most of these are considered to be sarcastic and surveys of biodiversity. And of course, there are questions about the long-term effectiveness of such strategies because the ecological successional strategy, there are so many questions. Big topic, I'm not going to detail. But still, there may be transition to lower and less valuable from an ecological perspective species on the farmland, but still, carefully from the farmland, erosion of farmland biodiversity is a major threat, especially they are important, especially from the perspective that they are important in maintaining pollinator populations and providing a whole range of ecosystem services. So, but home gardens in many places are becoming extremely Kerala. I think the considered loss of traditional home gardens with the advent of market economy, constant emphasis on maximization of production and so on. We have seen that many home gardens, traditional home gardens, are converted into tea gardens, tea garden, and fragmentation, commercialization has also resulted in the in the decline in the structure and functions of the Indonesian Pekaringan and traveling cable system. These are Indonesian home systems. Pekaringan, Indonesian language, Bahasa Indonesia, Pekaringan and traveling cable. Commercialization has resulted in the decline of these. Okay, so the government has in 2014 launched the National Agroforestry Policy to promote agroforestry. So you can see, the crumbling. The agriculture and forestry traditionally has been treated as separate watertight compartments, so which probably is not justified because they are kind of interlinked. Forest, agriculture cannot exist. At least agriculture cannot survive without forests. So there's a strong linkage between these two. But traditionally, all over the world, forests and agriculture were treated as separate, or it's a kind of false dichotomy that existed between these. Okay, and this policy actually aims to kind of bring convergence between those two. Okay, National Agroforestry does not create a separate policy window. You can see the then President Pranab Mukherjee launching this policy at the 2014 World Agroforestry Congress, which we held in organized in Delhi. Okay, it aims to harmonize policies on herbicides, agriculture, and forestry. It is expected to facilitate study, research, and growing market access. So, my last slide. I hope I did not exceed the time too much. So, integrated smallholder production systems involving tree crops, such as tropicals, palm gardens, agroforestry, and they are widespread in most parts of the tropics in India elsewhere. Agroforestry is considered to be an important strategy for achieving the so-called net zero emission target, because carbon stock changes and agroforestry can bring about. Because we have 120 million hectares of degraded land. If half of that, but our NAPCC 2009 National Action Plan for Climate Change, which was launched in 2009, it had a target of bringing 1.5 million hectares of degraded. We have 120 million hectares. Of that, every year, every year, 1.5 million hectares. But then they did not achieve any of this million hectares. And subsequently, the target was also revised. I think now the present India is to have 3 million hectares totally 2024. Okay. So earlier, the similar story earlier. Some of the senior faculty colleagues might know. Earlier in the 90s, late 80s, now when a forestry was forestry education was at a kind of watershed again, 1984, 85. So that time they also, Government of India launched so-called National Wasteland Development Mission. I think they were given a target of foresting or reforesting 5 million hectares every year of this 120 million. But they did nothing, and eventually this National Wasteland Development Mission was abolished after 5 years or so. So agroforestry can, if you can afford us about at least 25% of this 120 million hectares. The area currently is something like 25 million hectares in India. But if we can afford us 25% of this 120 million, so this will be a significant boost as far as achieving these methane carbon emission targets are concerned, net zero emission targets are concerned. Okay, so from that perspective, agroforestry has got great role. And of course, adopting the best management practices, including the so-called industrial agroforestry models or intensive short rotation silvicultural practices. All these will help augmenting soil and also biomass carbon stocks. The government have made bold initiatives. I mentioned about the agroforestry policy. Although policy was launched, I think that follow that is probably not as expected. There's only a very small program for agroforestry launched by the Government of India, because that SMA, some mission on agroforestry, which is under the NMSC, National Mission on Sustainable Agriculture. And it's a very kind of minuscule budget and all. So, even these states, I don't know about Tamil Nadu, did they implement There's a subdivision on but many states, I not read down, I think Kerala is not. So many major states have, all the bigger states like Andhra or Maharashtra and Uttar Pradesh are done that. But many other states are still, I mean, it's a very small program. We probably need to do more. Okay. I mean, just policy, even the policy itself has got some loopholes. We probably need to kind of bring in more comprehensive change in the national agroforestry policy. So agroforestry clearly can play an important role in providing food and nutrition security. I did not talk much about that, but certainly how far and harvesting the biodiversity accomplish, achieve food and nutrition security. We provide nutritious foods, vegetables, and also medicine, so many things. Maintain biodiversity. So I consider the agroforestry as a win-win strategy as far as accomplishing the net zero emission targets are concerned. I think on that note, let me conclude. I once again express my sincere gratitude to Dr. Subramanian and also Dr. Usha Malini, Dr. Basu for inviting me and for this lecture, and also Dr. Usha Malini for coordinating all the connected activities, and all of you and also all the students and others who have joined online for the patient listening. Thank you very much. If you have some questions, I will be happy to respond to that.
A few questions. Nature-based solutions now is becoming a lot of importance. I explained about maybe money for the what about your personal view about nature-based solutions?
Yeah, see, nature-based solutions clearly have certain advantage because we are following the nature's trajectory as far as this is concerned. Like, we are talking about agroforestry, one of those examples of nature-based solutions. So this is carbon sequestration through agroforestry is cheap. But there are industrial models, these are man-made. So many of those cap and trade schemes, to cap at source and then transport or maybe store the carbon in underground, reservoirs, capital intensive. Also, nobody knows about the kind of ecological outcomes of that. So cost factor ecology. But many of these nature-based solutions for carbon sequestration or even for conservation of biodiversity, these are environmental. Here, these are low cost. These are cost effective, and therefore ecologically sustainable. So ecologically sustainable. So certainly they have, of course, now different times. You find different terms. We will invent new terms to kind of gain attention and popularity. Nowadays, we also hear a lot about regenerative agriculture. But most of these are actually old ones. Regenerative agriculture, short and slight, the forestry is the form of organic agriculture is another form of regenerative agriculture. No-till farming, so everything has been there now. Repackaging or repackaging the same in a different form. So that's a kind of jugglery of phrases and jugglery of words. Nothing new in all these things, only kind of repackaging. So nature-based solutions, conceptually, they are good. In my opinion, they are very good.
Operationally, we have to do it.
Yeah, efficiency wise, the amount of carbon, of course, it is cost effective. And we're talking about carbon sequestration, agroforestry or other forests. These are cost effective. But the amount of carbon compared to those industrial models like Capcom, buried in deep sea aquifers, amount of carbon stored may be less. And some of this carbon also may be released. So there are two sides for getting it. But these are certainly cost effective and also ecologically viable.
Any questions for students?
Sir, nowadays there are a lot of companies and organizations coming forward to start the trading. So India, anybody has got any money out of carbon trading? today, if it is the case, what is the quantum of additional money they are paying out of the carbon credit?
Okay, if I understand your question, this is relating to land use?
Yes.
CDM?
Yes.
Oh, land use CDM, energy there are many.
Okay.
Land use there are very few. Some time back, my information back, the number is not up to date. I think 2012 or so, I was kind of viewing the number of CDM projects in India. At that time, the university website, there were something like 12 or 13 projects registered. And only 3 or 4 were operational. I think one was in Tamil Nadu, one in Haryana, and one somewhere else. There were three or four. So afterwards, after this, that was the time when carbon prices were very high, like $2 or whatever, $2 per ton. But then there was a crash in the price. So there are not many land use related CDM projects which are functioning as of now or even last 5 or 6 years. But there were 3 or 4, I know.
Any farmers get the money out of it?
Oh, well,
Irrigation growers?
okay, so I think I showed a slide, participatory carbon sequestration projects. So in some countries, I don't know about in India, I doubt. India,
India, Karnataka, they subscribe people.
they are giving money to farmers? Could be, okay. So there are, these, I know about, but there are only, I must say that there are only a handful of land use related CDM projects in India. Okay, some of these are some of those participatory, so-called successful international participatory carbon trading schemes. None of these listed are from India. Well, like this, the informed community, so the community was planting teak, okay, in Thailand. There's a guy I know who is an Indian State University, his name is Samit. So they were overseeing that. So he claimed that they were trying to give, but finally money was given or not, I cannot answer. I don't know. And then this Scholar Tea project in Mexico. Because the authors claim that, something like I published a book on, edited a book on carbon sequestration. So the authors of all these were contributing chapters to that, all these people. So that Mexican lady also was claiming that on could be given. Of course, he did not say on was given or not, it could be given. So some people, some of these places like Costa Rica, Mexico, on the farmers, like Costa Rica, there is another scheme called PES, which is very kind of function, payment for the ecosystem service. So farmers are looking to use all their farmlands, they take some money. Get some money. Of course, in Europe also, for some of you must have heard about the European Common Agricultural Policy. This Common Agricultural Policy in Europe actually has provision for paying farmers for return fees on the farm. During the discussion for our national agricultural policy also we made this point. But then our bureaucrats in the Ministry of Agriculture are not very receptive to the idea. So just short it down. But maybe isolated cases are there. I don't know the latest. But now the land use related CDM projects are, if you look at the university website, land use related CDM projects, you don't find anything from India. Earlier, few were there. Some of them must have done money. Okay.
As you were talking about the carbon situation, how far the Indian farmers will influence the carbon situation? Does it really have an impact?
Oh, yes. Chile, they actually, intensive to versus country. So if you have, you have finished the question. So Chile operations generally, kind of increase the oxidation of soil organic matter. So carbon dioxide emission takes place when you bring intensity like this can intensify heating whatever you do, or the soil organic carbon, which is lying below the surface, get exposed to direct beam solar radiation. soil gets heated up, and then that process, the oxidation, basically an oxidation of soil organic matter in the document. So this process is accelerated actually. So intensive tillage, generically saying, will increase the rate of soil organic oxidation and reduce the soil organic carbon content, and therefore adversely affect the agricultural crop. But you do not tillage, you do conservation agriculture, then this tillage is taken out of the scene, and then there will be accumulation of carbon. So that is why conservation agriculture. I just consider it is called one of those regenerative, one of those forms of regenerative agriculture. Nurture. Nurture is just for soil carbon. Again, available literature shows nurture is good for soil. Conservation agriculture, when it's conservation agriculture, as you probably know, has three pillars. One is, mulching, crop stubbles, crop resistance from the soil surface. That act as a mulch and prevent the rate at which or reduce the rate at which soil organic matter is decomposed. And then of course, in the crop rotation, all those are major pillars of the so-called conservation agriculture. So conservation agriculture, experimental evidence have shown that conservation agriculture can increase soil organic matter, and therefore the reduce organic agriculture. All these processes can augment soil organic carbon stack by reducing the rate at which it is oxidized. And if oxidized, not carbon dioxide emissions. That process is slow down or reduce. So these no-till conservation agriculture, all these are helpful in conserving soil organic carbon. That's why carbon is. Did I answer you?
And one more thing, like how futuristic it will be like you will be learning about biochar. There should be the regulatory for plant management in the near future. The investment in this biochar as
There are many people who think that biochar is a kind of revolutionary advance that we have recently. So biochar clearly it can augment soil carbon stock. Then also it acts also as a reservoir of soil nutrients. So it is fine. The information that is available to me clearly says that biochar is a key.
how far it can involve in the plant disease management.
Soil
Plant disease management.
for disease management. So, I would say that, better soil organic matter, addition of biochar, and for a longer period of time, may increase the vigor of the plant. When the plant vigor is increasing, or even the soil micro environment is improved. Better control the so the underlying soil carbon is always used. Better vigor means better resistance, better tolerance.